Question 8. Now, despite the fact we're given plenty of trig identities, again, unfortunately, this question doesn't provide any that are of any use to us. We need to be using this that needs to be learnt. Okay, you need to learn that a cos theta minus b sin theta can be written as r cos theta plus alpha, where r cos theta equals a, r sin theta equals b, and r equals the square root of a squared plus b squared. I'm afraid you've just got to learn that. Given you have done, this is fairly straightforward, because a is the, we can see, is the integer in front of cos theta, so that's 2. B is the taking away, then it's the integer in front of sin theta, so not the minus, it's just the b bit, so that's 3. And our angle theta is obviously 3x here. So r, as we can see, is the square root of a squared plus b squared, so square root of 2 squared plus 3 squared root 13. Now, given that r cos alpha equals a, we can root 13 cos alpha equals 2. So dividing by root 13, we can see that cos alpha is 2 over root 13, inverse cos in radians. We need to be working in radians here. Look, do you see our boundaries? So working in radians. So inverse cos in radians, we get alpha being 0.983. So setting it out in the required format, we've got r, which is root 13, cos open bracket 3x plus our alpha of 0.983. Now, part B is a fairly straightforward, I think, differentiation. We're differentiating this, which is two terms being multiplied together, u times v. So u is e to the power of 2x, v is cos 3x. So du dx is 2e to the power of 2x, and dv dx is minus 3 sin 3x. So the just using the product rule, we've got u dv dx plus v du dx. So substituting in appropriately, we get this. We can see we've got a common factor of e to the power of 2x, so we can take that out, giving us this. I've then just rearranged it to make it more in line with what we're aiming to, we're trying to show. So I've just changed it around to have the 2 cos 3x first. To bring it more in line with over here. We can then this then allows us to go and replace 2 cos 3x minus 3 sin 3x with r cos 3x plus theta straight from what we've done in part A. So I've just changed that around there, just putting the cos term before the sin term, and to see that it's a straightforward swap of that with that from part A. So this then further allows us to factorize and take the r out. So we've got r e to the power of 2x times cos 3x plus alpha as required. Now for part C, we're really just being asked to find the turning point, so where the differential equals 0. So all I've done is starting off with this. I've just substituted in what we know r to be, root 13, and what we know alpha to be, which is 0.983, giving us this. Now two things multiplied together equaling 0. Well, this is a constant. This never equals 0. So we can focus on this second part, the cos 3x plus 0.983 equaling 0. So let's inverse cos both sides, so we get 3x plus 0.983 equal pi over 2. Remember, working in radians. Divide by 3, we get this. Pop that into a calculator, we get 0.196.